Good afternoon, everyone. Thank you for being here today. My name is Manon Palaric, and I'm very happy to present the research I conduct as part of my final year thesis in psychology. The title of my project is The Impact of Generative AI Use Policy in Academia and the Role of Technostress on Student Attitudes. In this presentation, I will explain why I chose this topic and how we relate to AI's growing role in education. I will introduce the concept of technostress and explain why it matters when studying how students respond to AI. Then I will walk you through my quasi-experimental design where I test different levels of AI use in classroom setting. I will share the research question, present a summary of the main result, and end with the key implication for education and future research. Generative AI tools like ChatGPT are rapidly transforming education. Students use them to brainstorm, revise, and support their learning. Yet, many institutions remain uncertain about how to regulate AI use, with policy ranging from strict bans to full encouragement, often without considering the student perspective. That's what led me to this research, to understand not just if students use AI, but how it impacts their learning experience, motivation, and engagement. Students like Karudin and all show that when AI is used in structured and supportive way, it can enhance autonomy, collaboration, and participation. However, its effectiveness depends on how it is framed. Satisfaction drops when AI is used passively, such as only for literature searches. In short, AI doesn't just change what students do, it changes how they learn. And understanding that shift is essential for building more thoughtful, student-centered policies. When generative AI entered the classroom, professors responded in very different ways. Some chose to ban it completely, others allowed it under strict conditions, and some have fully embraced it as a learning tool. At York University, for example, several professors shared their strategy during a workshop organized by the Teaching Commons. One has students use AI to design bikes, coding tools like ChatGPT, books in library for creativity. Another taught students to use AI ethically, encouraging meaningful conversation with the tool. A third showed how AI can act as a personal tutor, especially in math. And to complement the strategy, Shakti's and all surveyed students to explore how they actually feel about using AI in their learning. So integrating AI in education opens exciting possibility, but it also brings new pressure, especially for students still learning how to use these tools. So while some feel curious and motivated, others feel confused and anxious. Without support, these feelings can lead to technostress. First introduced by Broad and developed by Tarfadar, technostress has 5 sources: techno overload, too much work too fast; techno invasion, no boundary between school and life; techno complexity, tools feels too hard to use; techno insecurity, fear of being left behind; techno uncertainty, tools keep changing, rules unclear. All of these remain highly relevant in the age of AI. A study by Upadhyaya and Virendra showed moderate to high technostress level, especially in overload, invasion, and uncertainty academia settings. Triggers include managing multiple platforms with tight deadline, late-night academic alerts, unclear rules about AI tools like ChatGPT. In short, AI can empower, but it can also create invisible barriers. So this study investigates how university policy on AI use, whether mandatory, limited, or prohibited, affects student learning attitudes. It also explores whether these effects depend on the student level of technostress. This searches as many hypotheses. First, students exposed to a mandatory AI policy will report a higher task-related anxiety than those in the limited or prohibited condition. Konk and all found that imposed AI use without clear support increased technostress. Second, students in the limited AI condition will perceive a higher task value compared to those in the mandatory or prohibited condition. According to Carradine and all, AI use is positively perceived when it is active but structured, enhancing curiosity, satisfaction, and sense of progress. In contrast, overuse or absence of AI lower perceived utility. Third, students with a high level of technostress will report a lower activity self-efficacy regardless of AI policy. Vendra showed that technostress correlates with reduced confidence in handling an academic task, especially when digital tools are perceived as complex. And last, students without technostress exposed to a mandatory AI policy report high intrinsic motivation than those in other groups. Con and O suggests that stressed users, when faced with mandatory tech use, are more likely to be driven by external pressure and institutional expectation, which align with intrinsic motivation profile. So here is a flowchart outlining the procedure that participants follow in the study. Students were asked to imagine that they were enrolled in a political science course and they had to complete a final assignment. The task was to write a 2,000-word essay on the topics, the role of government in addressing social inequality. So participants were randomly assigned to one of the three experiment conditions. The only difference, it was the guidelines regarding the use of AI tools. In the required conditions, students were asked to imagine that using generative AI was a mandatory part of the assignment. They were encouraged to use it for brainstorming, outlining, and reframing ideas, but not to write the paper directly. They also had to include a brief reflection on how they used AI, which should they use, and any change they faced. In the limited conditions, students were allowed but not required to use it. They could use it to support tasks, but not for fully writing section. They had to include an appendice explaining whether they used it and how and what tools they used. In the prohibited conditions, students were told not to use it at any stage, and they had to include appendices confirming they did not use AI. To measure student attitude, I used the Motivate strategy for learning questionnaire, also known as the MHLQ. For this study, I focused on 5 specific subscales that are the most relevant to study the cognitive, affective, and behavioral response of students to academic tasks. So first, the intrinsic motivation, it's the learning for personal interest. The extrinsic motivation, the learning for external reward. The self-efficacy, the confidence in the ability to succeed, the task value, how meaningful they found the task, and the task anxiety, the level of stress they feel about academic performance. Each subscale is made up of several items reflecting on students' perception and attitude toward the learning context. I include an attention multiple choice question to ensure participants were reading the instruction carefully. This is a standard practice in a survey-based research to maintain quality data. To measure participant level of technostress, I use the technostress character inventory. We produced a total score out of 135, representing each student's overall level of technostress. In order to analyze the influence of technostress on attitude, I needed to compare students with different levels of stress. That's why I used the median split. It allowed me to divide my sample into 2 groups based on the median score. The cutoff point was 84 in my results. Students with a score of 84 less were placed in the low technostress group, while those scoring above 84 were assigned to the high technostress group. 83 participants completed the survey, but from that I had to exclude 16 because they failed the attention question and 1 because they declared having a poor English understanding, which led to my final sample of 66 participants. They were equally practically in each of my experimental condition, and most of them were female with 85.7%, 12.7% of male, and 1.6% of non-binary. They were most of them in social science and education, and most of them were aged between 18 and 21 years old, and also between 22 and 25 years old. So this graph illustrates the results of the MANOVA I conduct, focusing on the 3 global effects tested. So the technostress, the AI policy condition, and their interaction. Each bar represents the P-late trace, which indicates how much overall impact each factor had on the student outcome measure in the study. The AI policy conditions that show that the highest place trace, suggesting a moderate overall effect, even though it was not statistically significant. The interaction between technostress and conditions show a smaller effect, while technostress alone had the lowest P-late trace, indicating a weaker influence on student attitude overall. Together, these results indicate that while no global effects reach significance, the high policy conditions still stand out the most influential factor on the combined attitude. This could be a signal worth exploring further in the future research. Since the MANOVA did not reveal any statistically significant global effects, I then conduct a series of univariate ANOVAs to explore the effect of the technostress and the eye condition on all individual attitudes. This allows me to examine more closely the 5 dimension and to identify potential trend or effects. So on the x-axis, you see the 5 attitudes we measure. For each variable, the yellow bar represents students with low technostress and the orange bar, students with high technostress. The height of each bar shows the average score for the attitude, and the black line indicates the standard error. For each variable, I have included PT, the p-value of the effect of technostress alone, the PC, the p-value for the error policy condition, the PCT, the p-value for the interaction between the two, along with the corresponding effect size. You will also noticing some red bar under some specific values. This highlight interest trends. So for extrinsic motivation, we see a significant effect of the AI condition. This is the only significant result in the model. We also see a trend in the attraction effect, suggesting that the relationship between policy and motivation may depend on the technostress level. For the auto-efficacy, although the effect of condition is not significant, the effect size is moderate, suggesting something is happening there. And finally, for anxiety, there is a trend with the effect of technostress nearly significant and an effect size moderate, meaning the difference in anxiety between low and high technostress students could be meaningful. In summary, while most effects were not statistically significant, the data point towards meaningful trends that could become clearer with larger sample size in future research. Among all the attitude measures, extrinsic motivation is the only one showing a potential significant effects. That's why I choose to highlight it with a separate graph, comparing the 3 AI policy conditions. Students in the limited condition report notably lower extrinsic motivation than those in the prohibited or required group, which had similar higher score. The Turkey post-hoc test support this trend. Although not statistically significant, these results are backed by a moderate to large effect size, suggesting that unclear or restrictive AI policy might reduce motivation while clear rules help maintain it. So extrinsic motivation was the only outcome showing a potential significant effect based on the AI policy condition. Other non-significant but moderate effects were also observed. Technostress on anxiety, AI policy on auto-efficacy, and direction on extrinsic motivation. This result suggests that extrinsic motivation is particularly sensitive to the clarity and coherence of AI policy in educational settings. Policies perceived as unclear or restrictive, such as the limited condition, may lead to the lower student motivation, while clear and consistent rules appear to support it more effectively. So size sample may have reduced the power to detect significant multivariate effects. Some effects, though non-significant, are still not worthy due to their moderate size effect. Participants may have not fully engaged with the hypolice instruction, and the manipulation may not have been strong or explicit enough. The use of hypothetical assessment may limit the real-world relevance of the result. Finally, not revealing the study true purpose may have reduced participation around to the experimental condition. So my direction for the future research will be to replicate with larger sample to confirm observed trend and statistical power, explore an alternative AI policy design and how they shape student attitudes, investigate interaction and mechanism between AI policy, clarity, technology and student motivation to better understand underlying psychological process. Future work could focus on how to support teacher and professor in integrity AI effectively while avoiding technostress, encouraging co-construction of AI guidelines with students to improve relevance, acceptance, and trust. As a key takeaway, I would say that the importance of clear effect is a result too, and it reminds us that policy, perception, and pedagogy are still evolving alongside AI. In a world where AI is rewriting the rule of education, understanding how students adapt is not just important, it's urgent. Thank you for listening. Don't hesitate to contact me if you have any question.